Screencast 5.5, Bohr's Epiphany. We're going to show how the atomic emission spectrum will reveal to us where the electrons are. This image here should help a little bit. If you take, say, a pure element, such as, magnesium, and you hit it with a flame, heat it up tremendously, you will see an atomic emission spectrum. And it's a series of sharp lines. There's information there. Bohr used that information to figure out exactly where electrons are, at least to a better approximation than was known before. Here's the story of Bohr's epiphany. Every element has an atomic emission spectrum. If you heat it up and run it through a prism, each of those lights will separate into their component wavelengths and give you a nice fingerprint. What does that mean? Also, be aware that these lines are ultra sharp. Isn't that unique? There must be something going on there. There must be some information about atoms that's being revealed. Since the nucleus is essentially a lockbox and requires just phenomenal energy to mess with it, it's got to be all about the electrons. There's electronic information here. Bohr knew that, and he wanted to solve this riddle. How do you solve it? Well, why don't we start with the simplest atom, the one that gives the fewest lines. Not this guy, but this guy, hydrogen. It just gave these 4 lines here, and there's 4 numbers associated with it. Well, there's the numbers: 656, 486, 434, and 410 as you work your way down to smaller wavelengths. And they tended to use nanometers. They like nanometers because it's a convenient number. The first thing that people did with it is they looked for a mathematical pattern. And it's not a simple pattern, but it is a pattern. It took a long time, but simultaneously a couple of scientists hit on the pattern. This was Balmer and Rydberg. It became known as the Balmer formula, and this number here became known as the Rydberg constant. You can predict this number. The wavelength in nanometers is equal to 1 over some number times 1 over what I'm going to write inner squared and outer squared. And I'm revealing a little bit about Bohr's discovery, but it's going to work. These are just 2 numbers, A and B. And outer is always a bigger number than inner. Let's have the outer be 3 and the inner be 2. Go ahead and solve this, and you should get one of these numbers. I think you will. Put a 3 there and put a 2 there and solve it. You should get 656. So that would be for this number 3, that number 2. You put in other numbers and you'll get these other ones. The cool thing about this is you can throw in numbers that are higher or lower and predict what happens next. I think the next number is 397. You can go out in this direction and find out what the pattern is. It's got something to do with electrons. This inner and this outer might be a little too helpful, but that's the Balmer formula, and it allows you to predict the wavelengths of light that would go outside of the visible spectrum. They'd go from red to infrared. They'd go from violet to ultraviolet. This is leading to Bohr's epiphany, and this is Screencast 5.5.